this video, we're going to take a look at some of the limitations of GDP, or that is to say, some of the considerations that we need to understand before we really use GDP as kind of the be-all, end-all of economic activity. So these first three items here in this list, quality of life, population, and price levels, are important things that we need to consider when we talk about using GDP as an indicator. And the first is that quality of life is not part of GDP. And so there's a very famous speech by Robert Kennedy about GNP, which is a similar measure of economic output. And he essentially argues from 1968 that GNP measures everything that we don't really want, actually. And it's a poignant speech, and I encourage you to go seek it out on YouTube. But that is one piece of this that we need to observe, that we don't measure infant mortality or life expectancy or how many girls are going to school compared to boys. We don't measure income distribution. We don't measure pollution. It doesn't tell you how polluted or how clean the water is in a particular country. So the second thing that we need to consider is the population. If we're going to compare two countries, right, let's compare the United States and China, adjusting by population gives us something called GDP per capita. And that's a very important aspect of comparing countries, because a larger population means you have more economic activity. So being able to compare countries with population is important. The third item here is price levels. And there's two things going on here at the same time. One is that in some countries, the prices of goods and services are very high, and in other countries, they are very low. So, for example, in China, the prices of many goods and services are relatively lower than they are in the United States. And in the United States, things are relatively more expensive than they would be in China. If we adjust for that, we actually find that the Chinese GDP goes up, because the price of a taxi cab ride, a short ride in China, might be only a few dollars. And the price of a taxi cab ride in the United States might be $20 or $30. And so if we adjust them, then we actually find that the Chinese have the largest GDP in the world. So the Chinese have the largest GDP in the world using purchasing power parity. Now, if we didn't use that, the United States would have the largest GDP in the world. The other thing that's related to price levels is that we need to adjust them based on their price levels over time. And so if we wanted to compare, say, the United States in 1955 to 1985 or to 2015, we would need to know what the relative prices are, the changes between those years, because prices were lower in previous years. So the way we do that is by using something called nominal and real values. So this purchasing power thing, we're not going to necessarily need to be able to figure out how to calculate all of that, but it is an observation to know. But we do need to know how to do this stuff, the second part. So nominal GDP is a word we haven't heard before. Nominal just means in this current year. So it's GDP in current year prices. So let's practice that here. 2015 nominal GDP, and we have output and we have prices for 2015. So there are 5 widgets times $4. 5 times 4 plus 2 grebes times $5 a grebe. 2 times 5 is 30, so $30. And then we find the nominal GDP in 2019, and we say 10 times 4, because this is 2019, 19. So that's 40, plus 4 times 10, it's another 40, gives us 80. And what we find here is this is telling us that the GDP of whatever this country is has more than doubled, right? It went from 30 to 80. That if it doubled, it would just be 60. But let's take a look at the amount of output for a second here and see if it actually more than doubled. 5 became 10 widgets. 2 grebes became 4 grebes. So output actually only doubled. But what our numbers are telling us is that it more than doubled. So we need some sort of tool to make this 80 the correct number. Now, we're going to calculate the correct number here using what's called real values. And so they're kind of correct. It's not saying that nominal is incorrect. It's just saying real is perhaps more accurate, by using the prices of a base year. So what we're really doing when we say this is we're going to pick a year, and we're going to keep using those prices year after year after year after year. We're never going to change the prices. We're only going to change the amount of output. So in this one, we say the base year is 2015. So that's the year we're going to pick. So we're picking these prices. And we're going to say, okay, the real GDP in 2015 using these prices is 5 times 4 and 2 times 5. So that's 30. So we notice, though, that the nominal is the same as the real. Well, that's always going to be true for a base year. Now, for base year 2015 real GDP in 2019, we're going to end up with a different value from 80. It's going to be 2019's output and 2015's prices, because this is the base year. So 4 times 10 is 40, and 5 times 4 is 20. So 40 plus 20 is 60. And lo and behold, we find that it actually does double here. The real GDP doubles between those two because what's actually happening is the output is doubling between those 2 years. Now, economists have developed something that allows us to shrink the 80 to the 60, and we have a shorthand little tool that allows us, like a balloon, to kind of deflate this 80 nominal value and deflate out, kind of take out from the air of that balloon all of those price levels and make it down to the correct real number. And economists have this tool to deflate GDP, and we've come up with a really good name for it. It's called the Gdp Deflator. So this is just an index value that allows us to convert quickly from nominal to real. So for example, if the deflator is 150 and the base year is 100, that also tells us that there's 50% higher prices. So we can kind of quickly see price level changes in an economy as a result of the deflator. And so it's just a price index of one of many that we're going to be looking at. Now, the formula is quite simple. It's the nominal value over the real value times 100 gives the deflator. So pretty straightforward. And n comes before r, so that can help you there. N comes before r. Nominal value times the real times 100 over the real times 100 is the deflator. So let's practice. If the base year is 2015, then the deflator in 2019, well, nominal is 80 over the real value, 60, times 100. Now, 8 over 6. 8 over 6 is 1 1/3, so that's 133. Now, what this is telling us, right, compared to the base year value, which would be 100, is that prices have increased 33%. And why is the base year value 100? Well, let's think about it here. Why would 100 be? Well, let's plug in the numbers. Nominal is 30. So this is for 2015, 30 over the real, 30, times 100 means the base year is, the deflator for the base year is 2015 is 100. So when you go from 100 to 133, that's a 33% increase in prices. Now, here's a quick question for you that you're going to see on a test. It's going to say, if prices went up 33% and you got an increase in your wages of 20%, are you better off or are you worse off? And as it turns out, if you get only a 20% wage increase and a 33% increase in prices, they didn't keep up. So you're worse off. So you have a negative real wage rate increase, right? It's negative. You lost 13%. And then the last thing that we have here is, why would real GDP per capita be different between two different countries or multiple countries? And it really comes down to productivity. Now, there are some factors related to productivity that I've listed here for you. We're going to return to productivity later on in this class and talk about how can we grow an economy and how can we make more real GDP per capita. But this is something just to kind of observe at this point. We're not necessarily going to do too much with it. So hopefully this helps you understand a little bit of the idea of GDP deflators, base years, and nominal versus real, and some of the considerations that we have when dealing with GDP. Bye-bye.